Welcome to Sherlock 2.0. Our sponsor is Dr. John C. Murray. My name is Stephanie Pena. I am the product manager. I am also part of the UI UX team.
My name is Elena Barisha. I'm also part of the UI UX team.
My name is Colin P. and I'm part of the machine learning team.
My name is Nicole White. I'm also part of the machine learning team.
My name is Victor Lazabon, and I'm also part of the machine learning team.
Sherlock is a web-based tool which helps understand human reactions to audiovisual stimuli by allowing users to upload biometric data, as well as upload and annotate videos of screen capture of media. Our goals for this iteration of Sherlock are to use machine learning to garner analytics regarding event detection, as well as improve the existing web application and implement a new user interface to display the machine learning analytics on a timeline. Sherlock was designed with game design in mind, so the immediate impacts would be allowing game developers to create more emotionally intense games. However, because Sherlock is a free and open source tool, it could reach beyond the scope of media, such as a training tool for professionals to ensure that they have appropriate emotional responses to stressful stimuli, or to help understand the complex emotions of underrepresented groups, such as individuals with disabilities like autism or ADHD.
So our project has two main components, one being the front end, which uses React.js. Our web application has all necessary functions such as user authentication, project creation and deletion, and data upload. Once uploaded, biometric data is fetched from the database and displayed using chart.js. Machine learning events are also overlaid in the graph. The other major component is machine learning, which uses Python. We wrote a peak detection program for processing heart rate, interval, and galvanic skin response data. It also processes facial action unit data by using a system to estimate emotions through a combination of activated muscles. We also analyze gameplay footage with a combination of facial recognition, character identification, and overlay eye tracking data.
For overcoming challenges, a significant component was communication and teamwork, which was handled through the use of virtual pair programming, screen sharing, progress, and always having an open line of communication through Discord, allowing us to communicate effectively while social distancing. COVID limited our ability to collect data, which meant that our machine learning development was delayed until after the in-person data collection was performed in early October. Additionally, since our project was the successor to the original Sherlock, we had to overcome difficulties with understanding and working with the previous team's code, as well as fixing any bugs. These limitations may have put us behind schedule, but once these roadblocks were removed, we worked quickly to get back on track.
The biggest lesson that we learned throughout this whole project was that challenges and setbacks are inevitable, so it's always important to have a backup plan and stay on track. Setbacks happen in the real world all the time, so this gave us really great preparation for our future careers. Anytime we received feedback, either from professors or a sponsor, we made sure that we kept an open mind and thoroughly understood what they wanted from us. In the end, we found it important to find a balance between all the feedback that we received to create a project that everyone was happy with. Our main motivation for the project was the idea that we could positively impact groups of people, especially those underrepresented in society. Another motivation is allowing researchers and game developers to improve their products.
So this is what a user sees when they access the user interface. There's a black box allowing a user to annotate the timelines with different scenes, beats, and choices that a player makes or sees during the gameplay or video. Further down, you can see the different graphs for heart rate, galvanic skin response, and interbeat interval. You can also filter these out to see the peaks that our machine learning model has detected after the data was ran through it. In the first graph, you can also see the emotion that a player was feeling at any point in the video due to the machine learning model, which made sense of the facial action unit data we fed it. We also have a sample of the machine learning model that we ran on the gaze point data. It shows the character with the bounding box around their face, and it also shows whether the user is looking at them or not, or where they are looking in general.